Ur and I are really apologetic that we couldn't come to Korea to be with you in person. And thank you for the 10-year Test of Time Award. Our paper in 2005 was One Size Fits All, an idea whose time has come and gone. The context for that paper was the previous 20 or 30 years. Our whole community was pretty much about making relational DBMSs the answer to any question. Make them as broad in scope as possible. During the 80s and 90s, lots of stuff was added to our DBMSs, abstract data types, referential integrity, et cetera, et cetera. The SQL spec grew from 100 pages to about 1,500 pages. And all of this was an attempt to make relational database systems the one size that fits all. By 2005, we sort of realized that was never going to work. And why we came to that conclusion was we were working on Aurora, which was a streaming DBMS, and it looked nothing like the traditional RDBMSs of the time. It just had no relationship to those implementations. We had also started working on CStore, which was a column store, although nothing had been published by then. But it was already clear to us that a column store looked nothing like a row store. And the paper in 2005 also talks a little bit about text. And it was evident just based on a sample of 3 that one size didn't fit all. And that was pretty much what our paper said in 2005. The team that worked on sort of in this area on this paper pretty much was Ur and I, but there were a bunch of other actors. Stan Zadanek and Mitch Cherniak were helping with the streaming stuff. Sam Madden was helping with CStore. Nesame Patatpul was also helping with the streaming stuff. So I want to acknowledge the rest of the people in the Brown MIT universe who were responsible for these ideas. 10 years later, not only does one size not fit all, but in my opinion, one size fits none. So the traditional row stores that are sold by the legacy vendors, systems like DB2, Oracle, and SQL Server, in my opinion, they are obsolete and are good at nothing. So 10 years ago, they weren't good for everything. 10 years later, they're good for nothing. So I want to go through a bunch of markets and explain why these systems are basically not good for anything. So let's start with the warehouse market. So in data warehouses, all the major vendors have now or soon will have a column store. Column stores are 2 orders of magnitude faster than row stores. There is a ton of evidence to this effect. So the data warehouse market is going to be entirely column stores, and it may take a decade for all the row store implementations to disappear, but there's just compelling evidence that column stores are faster, and all the new installations these days are all column stores. So let's look at another major market, transaction processing. The neat thing about transaction processing is the databases aren't all that big. A terabyte is a really big OLTP database, and you can buy a terabyte of main memory for maybe $30,000. So if you're interested in going fast, buy enough main memory and put all of your data in main memory. If you do that, you've got a very, very different implementation because the traditional transaction processing algorithms that are in the legacy vendors' row stores just are way too heavyweight. So all the new guys, and new guys mean Microsoft Hackathon, SAP HANA, and a bunch of startups. They all have very lightweight transaction systems that use totally different techniques than the traditional legacy row store vendors. So in the data warehouse market, you're seeing a different SQL implementation. In the OLTP market, you're seeing a different SQL implementation. In the last 10 years, I don't have to tell you, you can just listen to the news, there is a NoSQL market. There's 100 or so vendors. So there are a couple of dominant vendors and a lot of other folks. They have a potpourri of data models and architectures. There's no standards whatsoever. There's a bunch of key value stores, there's a bunch of record stores, there's a bunch of big table clones, there's a bunch of Amazon Dynamo clones, there's a bunch of JSON stores. Things are alive and well. We'll see how big this market will actually end up being. But in the meantime, there's a ton of ideas, and none of them end up looking like the traditional row stores from the legacy vendors. Let's move on to some other topic. So far, the analytics market has been what's called business intelligence. So business analysts use data warehouses and they run business intelligence products, things like Cognos, things like business objects. These are nice graphical front ends to SQL aggregates. So you can do count sum, max, min, average, group by, do standard SQL analytics. What's going to happen off into the future is that data scientists are going to replace business analysts. It may take a decade because we'll have to train a bunch of data scientists, but it is going to happen. And data scientists don't want to run SQL analytics. They want to run regressions. They want to find eigenvalues, eigenvectors. They want to do singular value decomposition, data clustering, predictive models, ... All this stuff is defined on arrays. It's not defined on tables. So it'll be really interesting to see how the complex analytics market unfolds as we train some data scientists to be able to do that. You can simulate all of this stuff in SQL, but it is really, really slow. You can cast tables to arrays and use some table add-ons. That's a little bit inconvenient. We'll see how well it performs. You can implement all of this stuff trivially in an array database system, something like ICDE. We'll see how that unfolds. You can certainly use what people do now mostly, which is run a stat package. But the trouble with stat packages is they have no data management in them. They're just plain statistics, and you need to do both statistics and data management. Jury's out on who will win, but the thing that's interesting is that it isn't all that likely that traditional row stores are going to get this market. It's likely to be either column stores, array stores, or maybe some sort of extension of statistical packages. The jury's out. Stay tuned. It'll be an interesting market off into the future. Maybe I can write another paper in a decade sort of talking about this. Next slide. Okay, the streaming market that we talked about in 2005 is alive and well, and it isn't based on traditional row stores. So stream processing engines have some of the market. So Storm is a popular one. Streambase is a company we started. There's a bunch of stream processing engines, and what they do is they're a workflow of record processing with very SQL-like characteristics. However, the thing that I think is kind of interesting is the main memory OLTP engines seem to have a greater market share of streaming real-time stuff than the stream processing engines do. And so you can view an OLTP engine as a message comes into an application, the application runs a stored procedure runs against the main memory database system, blindingly fast performance, essentially the same performance you can get from any streaming engine. So this seems to be a programmer preference issue as to whether you want a messaging architecture or whether you want a function call architecture. So those two kinds of engines seem to are the dominant ones in the streaming market. I just want to put in a little pitch for a thing called SStore, which Nesame Tatbul here at MIT is working on. So we built an OLTP engine, HStore, in the mid-2000s. We also built Aurora, which turned into Streambase. So we built two of these things, and if you want the capabilities of both of these systems, you can either add streaming to an OLTP engine, or you can add persistence to a streaming engine. It's a lot easier to add streaming to an OLTP engine, and that's exactly what SStore does. There's a paper on SStore. Check it out for the details. In any case, the streaming market is not going to be anything that has anything to do with traditional row store implementations. Okay, lots of people talk about graph analytics and graph databases. So Facebook has a big graph, and if you want to find the average distance from me to you, that's a graph analytics problem. How are you going to do graph analytics? Well, there's been a whole bunch of papers recently on how to do that. Some of them talk about doing this with a simulation on top of a column store, a standard data warehouse style architecture. You can certainly do graph analytics in an array engine. The edge matrix is simply a matrix. The node is a one-dimensional array. You can simulate this in an array engine. There are a bunch of special purpose graph engines, things like GraphLab, Giraffe, and so forth. The jury is out on exactly who's going to win this market, but notice that traditional row stores are not even on this slide. It's simply not going to be them. Next slide. So the summary is we've gone through most of the major markets. There's a huge diversity of engines. All of them are oriented toward a specific vertical or a specific application. And traditional row stores are good at none of these markets. And so as these markets expand in size, and as people get a chance to change vendors, the traditional legacy row stores are going to have no market share in any of these markets, i.e. one size fits none. So it's a great time to be a database researcher. Whenever the traditional vendors are the legacy code and there's a whole bunch of new ideas, it's a great opportunity for yet other new ideas. And there's a whole bunch of them that I think are going to be really significant off into the future. Non-volatile RAM is going to get here. Intel is predicting it within 5 years. It's going to be very cheap and very persistent, and is going to get rid of flash completely. And so how's that going to fit into DBMSs? Main memory databases are continuing to get bigger and bigger and bigger. There's going to be processor diversity. So we don't have to just run on Pentiums. GPUs, Intel Xeon Phis, NVIDIA GPUs, NUMA architectures, ... FPGAs, how to accelerate DBMSs using the processor diversity that's coming at us. Right now, as near as I can tell, in any multi-node DBMS implementation, networking tends to be the bottleneck, which is CPUs and disk bandwidth are not the scarce commodity, it's networking. There's a bunch of ideas on higher speed networks. We'll see how that all unfolds. LLVM is intermediate level language. Compiling database systems into LLVM and things that look like LLVM or higher level versions of LLVM may well change the way current database stacks end up being implemented. And as MonetDB showed us a decade ago, vectorization is an awfully good idea when you're reading more than a few records. So there's lots of things you can leverage, lots of markets, and we expect to see a lot of new implementations off into the future. So how are the elephants going to react to all of this? Well, you know, there's way faster implementations at what their traditional market is, lots of new ideas that could well be very disruptive. Well, there's a great book called The Innovator's Dilemma by Clayton Christensen, who's a Harvard Business School professor. Basically, his point of view is that whenever there's a transition from the old stuff to the new stuff, the vendors who are selling the old stuff have a very hard time morphing from the old stuff to the new stuff without losing market share. So we'll see how the elephants do. I expect that SQL and Hekaton, SQL Server and Hekaton lead the way. SQL Server 14 is in fact two engines that are two completely separate engines united by a common parser. One of them is traditional row store SQL Server. The other is a main memory database system called Hekaton. So I expect the legacy vendors will start stuffing additional engines underneath a common parser as they try and sort of morph from old implementations to newer ones, preserving their customer base. So as the elephants try to adapt without losing market share, I expect them to try and maintain a common user interface and simply flip out old engines and replace them by new engines over time. We'll see how successful that will be. However, I just want to draw attention to what I think is going to be the main tent conflict among the elephants. Most of you can probably surmise that SAP turns out to be Oracle's largest customer. Well, SAP customers running SAP are Oracle's largest customer. So SAP databases are largely staged on top of Oracle storage. You can imagine SAP is not very happy with that. And so they have a system called HANA. I expect off into the future to get an announcement at some point that either SAP doesn't support Oracle anymore, or that it runs differentially wildly faster on HANA. So I expect SAP to be dramatically in the database business and to be a major thorn in the side of Oracle. We'll see how all of this unfolds. Meanwhile, Oracle is hard at work getting you to run their proprietary hardware and get their Oracle suite of business products to increase market share. So they will be competing head-to-head with SAP. It'll be fun to watch from the sidelines how this all unfolds. So the ultimate summary, in my opinion, is for most of the 80s and the 90s, our field, DBMS research, was pretty much dead on its feet. And this resulted from our belief that one size fits all. We just had to polish up the relational model. But I think that philosophy is completely dead. And now we live in interesting times. There's all kinds of new ideas, all kinds of new implementations. It is a great time to be a DBMS researcher. And so I would encourage all of you to go out and explore this new space of implementations. Thank you very much for your time, and I hope I've made somebody mad so that you'll ask some questions. Thank you very much.